In this slide, we're going to discuss the relationship between angles in the coordinate system. Suppose I've given you an angle measure. Since this is a measure of a geometric angle, it's a length of a short arc of the unit circle, so it's a number between negative pi and pi. Now there are infinitely many geometric angles that have that measure. Just take any angle with that measure and just move it around and rotate it around in the plane, and you have infinitely many congruent angles with the same measure. Okay, but is there a best way of selecting one particular representative, one particular angle with a given measure? And the answer is yes. Now, of course, by saying best way, I mean best way relative to the choice of the coordinate system. So, suppose we have first fixed a choice of a coordinate system in our plane. How that choice is made, that's a different discussion. So we postpone that, leave that to the side. Somebody has made that choice. We have. Now, this means that there is one point, namely the center of the coordinate system, which is preferred. That's a point which is somehow distinguished among all points. So what we do when we want to choose a geometric angle with a given measure is we choose the best possible point for its vertex, namely the origin. Right? We have a distinguished point, that's the origin of the coordinate system, and every angle has a distinguished point as well, so it makes perfect sense to select the origin to be the angle's vertex. So that's, you could argue, the best choice you could take. The next thing you do is you need to select the initial arm of your geometric angle. What you do is you always select the x-axis to be your initial arm. And in the positive direction, not the negative x-axis, the x-axis in the positive direction. You always select that one to be the initial arm, right? Because to fix a coordinate system, you need to select an origin and you need to fix the direction of the x-axis. And so that's the most natural ray, if you will, is the first ray of the coordinate system, the x-axis. Okay, so now I've told you how to select the vertex and the initial arm. Now how do we construct the terminal arm? Once we have selected the vertex and the initial arm, if we know the angle measure of the angle, which we do in this case, that's the number alpha, then we have no longer any choice for the position of the initial arm. It is a function of of the choices we have made so far. So what we do to construct the terminal arm, the second arm of our angle. This is the first arm, this is our initial arm. So what we do is we take this point, the point with coordinates 1, 0, that point, and we rotate it along a circle whose center is at the center of the coordinate system. We go counterclockwise if alpha is positive, and we go clockwise if alpha is negative. And the amount of distance we travel on that circle is given by the absolute value of the angle. So here, the distance that you see here is given by the absolute value of alpha. Think about it. Such a system could actually be constructed in the physical world. So in the physical world, you could actually fix a pivot, make a solid connection between this point and the center of coordinate system, say with some rigid rod or something of the sort, and then you could actually rotate. While rotating, you could measure distance, say by dropping a rope or some other means, and so you could actually physically implement what we're showing here. So you could actually physically move a given distance, and the amount of distance we travel is alpha units. Then what we do is, we took that point, we traveled for alpha units along a circle, and we arrived at another point, and that point we use to select the terminal arm of our angle. So we use that point and we connect it to the origin, and then the ray formed in this process, pointing from the origin to that point, so that ray is the terminal arm of our angle. Now notice that at the start, this construction appears to work only for a geometric angle, right? We started with a geometric angle. So we started with an angle measure which was between negative pi and pi. So this number alpha was between negative pi and pi. But everything that we did, so we fixed a point and then we traveled a given distance. Okay? So everything that we did here could be carried out if the amount of distance traveled is bigger than pi units. So in this case, this would be pi units of travel distance, and I could travel on the other side as well. So the construction extends in a straightforward fashion for angle measures which are greater than pi radians or smaller than negative pi radians. Right, I could do more than 2 pi radians as well. In this way, for every real number alpha, we can assign a geometric angle. If the starting number was in the interval from negative pi to pi, the so obtained geometric angle does have the same measure as that original number alpha. But if the measure alpha was not in that nice interval, the measure of the geometric angle obtained by this construction will be different will be different. So the measure of the geometric angle would be different from the original number alpha, right? So if I started with if alpha was in the beginning 1 radian, and then I started with another alpha prime, which is 1 radian plus 2 pi. Well, so I would get again the same point, so I would get the same geometric angle. But the two numbers from which I started would be different. So if you wish, the assignment from an angle measure to a geometric angle is not one-to-one. It is possible to have two different angle measures which result in the same geometric angle. How is that possible? Well, just take one angle measure and add 2 pi units to it. Okay? Whatever you do, however, the only way for you to have the same geometric angle obtained by two different angle measures is to have that those two angle measures differ by a multiple of 2 pi. So by an even multiple of pi. So if alpha and alpha prime result in same geometric angle, that means that their difference, alpha minus alpha prime, must be a multiple of 2 pi. Or a multiple of 2 pi, that's the same thing as saying an even multiple of pi.